Good morning, students. Today we'll continue with the chapter complex numbers and quadratic equations. And the topic for today is polar form of a complex number. In the previous class, we have seen how a complex number is represented on a Cartesian plane, and that is called as Argand plane. And today we'll see the polar form of a complex number. The polar form of a complex number is another way to represent a complex number. The form z equals to a plus bi, which is called the rectangular coordinate form of a complex number. Okay, z equals to a plus bi, which is a complex number. It gives you the rectangular coordinate form of a complex number. By looking at this figure, it's a real x-axis and this is imaginary y. Simply we call it real z and imaginary z. And it makes an angle theta. Okay, it makes an angle theta with the x-axis. And the position point P here, which is represented as a comma b. So a and b means what? Distance from origin till here, this point. And b is the y-axis distance from the origin is taken like this. Okay, so P, point position P is A and B. And OP is the, what is the OP? OP becomes the modulus of Z. If Z is A plus IB, then mod Z equals to a square root of A square plus B square. So that is the value of R. We'll see how this thing is calculated. The horizontal x-axis is the real axis and the vertical axis is the imaginary axis. You find the real and complex component in terms of R and theta, where R is the length of the vector and theta is the angle made with the real axis. Okay, so R and theta is also called as polar coordinates. Polar coordinates, R and theta. So from Pythagoras Theorem, if you apply, this is an hypotenuse OP, okay, and if you apply, this is a right angle triangle, and if you apply the Pythagoras Theorem here, so R square equals to A square plus B square. So R square equals to A square plus B square. So what is R equals to? A square root of A square plus B square, which was nothing but the modulus of a complex number Z. Now by using trigonometric ratios, specific angles cos theta and sin theta, cos theta is based upon hypotenuse. Cos theta is based upon hypotenuse, or we can call it in other ways adjacent side upon hypotenuse. By looking at the figure, if theta is lying here, what is cos theta? Cos theta becomes, the base is A, which is the adjacent side, upon hypotenuse, which is R, right? So what is the value of A here? A becomes R cos theta. A becomes R cos theta, right? Similarly, for sin theta is perpendicular upon hypotenuse. Perpendicular is opposite side of the theta. So that is B upon R. So what is the value of B? B becomes R sin theta. Like this. So A becomes R cos theta and B becomes R sin theta. Remember, this goes under imaginary and this one is the real part. So rectangular form of a complex number is given by Z equals to A plus BI. Substituting the values of A and B here, what do you get? In place of A we have R cos theta, in place of B we have R sin theta, and taking R out as a common factor, it becomes R equals to Z equals to R cos theta plus I sin theta. In the case of complex number, R represents the absolute value or modulus, and the angle theta is called the argument of the complex number. So this can be summarized as follows. The polar form of a complex number Z equals to A plus BI is Z R cos theta plus I sin theta, where Z is the mod of, where R is the mod of complex number, which is given by a square root of A square plus B square, where A is R cos theta and B is R sin theta. and theta can be tan inverse of b by a. For a more than 0, theta is tan inverse of b by a plus pi. Okay, pi is nothing but 180 degree, or theta equals to tan inverse of b by a plus 180 degree, where a is less than 0. We'll solve one example here to understand this thing a little better. Express the given complex number 5 plus 2i in the form of polar. The polar form of a complex number z equals to a plus bi is z equals to r in bracket cos theta plus I sin theta. So first find the absolute value of r. So how to find the absolute value of r? R is nothing but mod of z, which is given here as square root of a squared plus b squared. So what is the value of a? It is number 5, and b is 2. So 5 square and 2 square. 25 plus 4 is 29, that is 5.39. Now find the argument theta, the value of theta. Since a is more than 0, the formula for theta is tan inverse of b by a. So theta is tan inverse of 2 by 5. This can be the value of 2 by 5 you can obtain from the trigonometric table, which is near about 0.38. Okay, so theta is measured in radians. Therefore, the polar form of 5 plus 2i is about 5.39, cos 0.38, and I sin 0.38, which was the value of theta, near about. And r you got as 5.39, approximate value. So this is how it is done. But however, in this class, in class 10th, you will not be able to use a trigonometric table because you will not get questions of that kind. However, how to understand this and how to get the value of tan inverse of 2 by 5, you can use and go for trigonometric table. Alright, that's all from today's class. You can solve more problems based on this. Thank you.